Till now we had seen that velocity and accelerations were pole apart. What do you mean by pole apart? Pole apart is 36 ka akada. If velocity is maximum, acceleration is minimum, and so on and so forth. Now let's see what's the relationship between kinetic energy and potential energy. This was the bob with mass m was moving into simple harmonic motion. Alright. So kinetic energy formula we know is half mv square. Now whenever we talk in terms of simple harmonic motion, we know that v is omega root a square minus x square, where a is amplitude and x is displacement, omega is angular velocity. Alright, so we substitute, instead of v we put in omega root a square minus x square the whole square. Now, so it is what? If we square this becomes omega square and the root goes off, so the formula turns up to be half m omega square and in bracket a square minus x square. Fine. Now we also know that omega square is equal to k over m. So omega square, instead of omega square we can write here k over m. M gets cancelled, so our formula also gets the form of half k a square minus x square, where k is proportionality constant. So the formula that we now have is half k a square minus x square. Then again we also know v is equal to a omega cos omega t plus phi. So instead of v we can substitute a omega cos omega t plus phi. So it is half m. Instead of this v, what we have is half m a square omega square cos square omega t plus phi. So this is yet another formula which we have got to keep in mind. So all these formulae we have got to keep in mind. This and this we have got to keep in mind. So Ek, that is energy kinetic, is half ka square cos square omega t plus phi. Half ka square. Why? Because we know m omega square is equal to k, so it gets the format of half ka square cos square omega t plus phi. Alright. Now see, so this, if we assume this to be theta, it is cos square theta. So energy kinetic is directly proportional to cos square theta, or rather cos theta. That cos theta is inversely proportional to theta. Like if it is cos 0, then the value is maximum, that is 1. And if cos is 90, then the value is 0 minimum, that is 0. Alright, so what we can say is, when would this have maximum value? This would have maximum value when cos has value 0. Thus can conclude that Ek varies with cos square theta. Ek varies with cos square theta. Now at extreme theta is equal to pi by 2. So at extreme theta is equal to pi by 2, and if theta is equal to pi by 2, the value that it would have is 0. So energy kinetic at extreme would be 0 as per the derivation, and that we have seen earlier also. Theoretically also we know the pendulum stops at extreme position, so velocity is 0. So that's what we got. Alright, so when theta is equal to pi by 2, that is at extreme, the value of Ek is 0. At the same time, if it is at mean position, that means theta is equal to 0 and cos 0 is 1. So energy kinetic would be maximum. So in order to get maximum value, it has to be cos theta has to be 0. So whenever it is cos square theta is cos square 0, the value would be 1. That is maximum. So revisit this formula. At mean position, theta is 0, and if theta is 0, then cos square theta would become 1. Now if cos square theta becomes 1, then it gets, the energy kinetic gets the maximum value, and the maximum value would be half m a square omega square. That's what we found it over here. Alright, and that's at mean position. Alright, at mean position theta is 0, so cos square 0 is 1, so it would have maximum value, that is, this would become 1. So as a result of that, Ek would be half ka square. So if we are looking into this formula, then the maximum would be Ek, the maximum would be half ka square. Why? Because cos square theta at mean position, theta is 0. So cos square theta would be 1. And if cos square theta is 1, then this value would be half Ka square, and that would be the maximum value. Alright, so that's what we have been checking here. This formula is applicable for finding energy kinetics at any position of simple harmonic motion of pendulum. These two formulas. Now let's proceed towards potential energy. Alright, now for potential energy, now just let's assume that the simple harmonic motion is in linear motion. So it has to travel from here to here, which is x, but to get better results, we have got to find it out in terms of small displacement dx and then integrate it for 0 to x. Alright, so let's see how do we do it. dW, small work is equal to, we know the formula of work is force into displacement, but this is minus dx because we know as dx is in this direction, but the restoring force is in this direction, so it's negative. So as dx is against restoring force, so it is negative. Alright, so F also we know is minus kx, which we have derived already. So when we multiply, what we get is kx dx. Now for work to displace from 0 to m, that is from 0 to x, to convert small work into big work, total work, it has to be integrated from 0 to x. Alright, so we do that. Now we already got this formula, we substituted that formula, and k we took it out of integration. As per rule, these constants are taken out of integration. Then x dx integrate from 0 to x. So we know the formula, integration of x dx is x raised to n plus 1 divided by n plus 1. So it was 1 over here. So it becomes 1 plus 1, that is 2, and divided by 1 plus 1, that is 2. So it becomes half kx square. Now again, as we substituted there, now here in this case we half m omega square x. Now here what we substitute is, we know x is equal to a sine omega t plus phi. So the formula gets the format of half k a square sine square omega t plus phi. Alright, now mind you, here we have talked about when it starts from mean position. Alright, it starts from mean position. So for mean position, we know this is it's the sine curve. Alright, so half k a square sine square omega t plus phi. So if we assume this to be theta, then we can say that energy potential is directly proportional to sine square theta. Mind you, energy potential is proportional to sine square theta, whereas energy kinetic is proportional to cos square theta. So this is cos, this is sine. So energy kinetic and energy potential also has 36 ka akada. And yes, why not? We know at extreme position velocity is 0. So obviously kinetic energy should be also 0. Alright, and if kinetic energy is 0, then your potential, E potential, has to be maximum. Alright, so because Ek is proportional to cos square theta and Ep, that is energy potential, is proportional to sine square theta. Okay.